Hi guys, welcome to the video again. Let's discuss about tutorial 1, patterns in the periodic tables. Without further ado, let's move on to the questions. Now, if you look at questions 1, write the complete ground states configuration for the following. Now, this is what we learned in high school, regardless of IGCSE or SPM. So lithium should have how many electrons? If you refer to the periodic table, lithium should have 3 protons and 3 electrons. So the configuration should be 2, 1. All right. Oxygen should have 8. So it's 2, 6. Calcium should have 20. So it should be 2, 8, 10, 8, and 1. Sorry, 2. My bad. So this is the configurations that you should have. Write it down. So titanium is 22. So just do it. 2, 8, 18, and then 4. 2884, 2882. So these are the configurations for the elements here. Okay, just revise a bit on this. Now, the last number indicates the valence electrons, and the numbers here indicates the electron shells. For example, lithium, I have 2 shells. Oxygen, 2 shells. Calcium, I have 4 shells. Titanium, 4 shells. And the number of shells also indicates the period number. Lithium, oxygen, both from period 2. Calcium, titanium, both from period 4. All right, so that's it for question 1. Let's move on. Now, question 2 is suppose independent learning. So this is for you to explore what is that abbreviated ground state electron configurations. So you should go online and search for that. Okay, if you are curious enough of that. Now, this is actually in terms of SPDF. Okay, some of you may have exposed to this. Now, this is up to you. You're going to search online and you're going to do it now. This is not as important. This is just for you to explore. We will actually learn that in details in the next semester. Okay, this is for you to play around with the electron configurations. All right, so let's skip that. I mean, with or without answer is fine. All right, I mean, you can ask me in details during tutorial for this. I can explain to you, but once you have explored it. All right, let's move on. Now, question 3, complete the table for the following table. So ionization energy general trend. So I'm sure by now you should know it. Ionization energy from left to right supposed to increase. Okay, ionization energy increases from left to right. Down the group supposed to decrease. Now, hope you can explain why increase and decrease in terms of across a period and down the group. So let me explain again a bit on this. Now, why ionization energy increases across a period? Because core charge increases across a period. Shielding effect stays relatively constant. Okay? And why going down the group it decreases? Because shielding effect increases, core charge remain the same. Okay? And that will be explanations if they ask. So atomic radius, what happened to the atomic radius when you move across a period? Atomic radius decreases and down the group increases. All right. Electronegativity tendency to attract electrons, to accept electrons across a period increases because stronger core charge, shielding effect stays constant. Down the group should decrease. Why? Because higher shielding effects. Okay, core charge will remain the same. So when shielding effect is higher, yeah, like I said, bistic dominance. So more repulsions, it is harder for you to accept electrons. Instead, it will keep repelling it off from the atom. All right. Repulsion is greater. Let's move on to question 4. Circle the atoms in each pair that has the largest atomic radius. So what happened? This is also can be done by referring to the general trend. So largest atomic radius between sulfur and oxygen. If you refer to the periodic table, sulfur, oxygen both from the same group. Oxygen followed by sulfur when going down the group. So of course, sulfur should have larger atomic radius due to higher shielding effect, same core charge. All right. For B, bromine and chlorine, again, they are from the same group. Going down the group from chlorine to bromine, therefore bromine is the one with a higher atomic radius, again due to higher shielding effect, same core charge. Sodium and aluminum both from the same period. So what is the general trend for atomic radius in a period? Answer is sodium, because atomic radius decreases across a period, sodium followed by aluminum. Therefore, sodium has a larger atomic radius. Oxygen and fluorine, same period. The one with the larger atomic radius is oxygen, okay, because oxygen comes first before fluorine in a period. Magnesium and calcium both in the same group. So going down the group, you should have a larger atomic radius, calcium. Okay, so that's the answer. If you have different answer, then let me know. I'll clarify for you during the tutorial sessions. All right, so let's move on. Number 5. Now, what type of ions are bigger than their parent atoms? Why are those ions bigger? Now, what type of ions? How many types of ions we have? We have 2. The main category, we have a cation, you have anions. All right, now cations is actually a positive ions. Anion is actually a negatively charged ions. So let's explain one by one. Now, what does that mean by bigger than their parent atoms? So for cation, the examples given will be sodium, positive ions, and the parent atoms will be before they turn into ion, which is sodium atoms. Okay, now what is the configurations? 2.8 after losing 1, and this is remain the same, 2.8.1. Now, when they want to know about the size, which one is bigger, which one is smaller, what do we need to compare? Same thing, core charge and shooting effect. So what is the core charge for sodium ions? Core charge will be proton number 11 minus, what is the internal electron now? Only 2, because losing the valence, you only have 2 shells. So minus 2, you get positive 9. That's the core charge for sodium ions. And what is the core charge for sodium metal atom? So for this, 11, still the same, because remain unchanged for proton number, minus the internal electron, which is 10, you get positive 1. All right, so in terms of core charge, sodium ion is much bigger. All right, sodium ion is much bigger. So then what about its shooting effect? Shooting effect means the internal electrons. So this one, how many internal electrons for sodium ions? I only have 2 electrons. This one, I have 10 electrons. This is internal electrons. Internal electrons. So which one having a higher shooting effect? Definitely the 10 electrons. And sodium ions only have 2, so lower shooting effect. Now, in conclusions, sodium ion has a higher core charge, and lower shooting effect. Less repulsion, stronger attractions. Hence, the answer for this is sodium ions will be always smaller than their parent atom. Okay, sodium ions will always smaller than their parent atom, which is sodium atoms. This is for positive ions. Okay, now let's look at negative ions. So for anions, chlorides, configuration 288, chlorine atom 287. Now, what is the core charge? Let's check. So what is the core charge of chlorides? So chlorine should have 17 proton number minus the internal electron, which is 10. You get 7. So this is the core charge for chloride. And what about chlorine? The core charge is 17 as usual, minus the internal, still 10. You get a positive 7. So in terms of core charge, they are the same. Okay, in terms of core charge, they are the same. But what about shooting effect? Shooting effect, you have how many internal electrons? I have 10. This one also? Yes, 10 electrons. Okay, now what happens if both having the same core charge and the same shooting effect? Still remember what I said just now, when you move across a period, even though they maintain the same number of electron shell, which means the same shielding effect. But the shielding effect does not stay constant, but it stays relatively constant. Why? Because when you move across a period, there are still an additional electrons added in to the valence shell. So these additional electrons will still contribute to a repulsion force. And this repulsion force will make the ions or atoms slightly bigger. So in that case, we can just look at it and see which one having more electrons. So obviously chloride, you have additional electrons because you have 8 instead of 7. Therefore, anion is actually bigger than their parent atom. Okay, so the answer for question 5 is anions are always bigger than the parent atoms. Why? Because an additional electrons contribute to a bigger repulsion force. Okay, so that's the answer for number 5. Let's move on. Number 6. Use the trend to predict which ions in each pair has the smaller ionic radius. Okay, A, between barium and iodides. Obviously, when you talk about smaller ionic radius in terms of positive and negative ions will always give you a smaller radius because of a stronger or higher core charge. So answer here is always positive. Okay, what about both positive, Fe2 plus and Fe3 plus? The one which is more positive. Aluminium 3 plus, P3 minus, apparently aluminium. Fluoride and chloride, now both negative nodes. Okay, so now you check. Both are actually with additional 1 electrons, which is the same. But fluorine has only 2 shells, 2, 8. Chloride has 3 shells. So answer is fluoride. Okay, because you have 1 less shell. And between potassium and cesium, which one is actually having a smaller radius? As usual, if you look at a group, potassium is from period 4. Cesium is much lower, higher number of periods, so definitely potassium. Okay, less shells. Okay, 7. It is easier to form positive ions with an element that has high ionization or an element with low ionizations. Now, which one has a higher ease of forming positive ions? First, to form a positive ions, an element or an atom must able to lose an electron. All right. In order to lose an electron, you need ionization energy. Okay. So those with low ionization energy, which means less amount of energy is able to remove an electrons from it. Okay. So therefore, the answer is which element is easier to form a positive ions? Elements with lower ionization energy, because less energy needed in order to form positive ions. Okay. Number 8, sodium, magnesium ions each have 10 electrons surrounding the nuclei. Same, because once they form ions, they should have the same configurations, which is 2, 8. Which ions would you expect to have a larger radius? Now, this one can be solved by using the core charge. So like I always compare, sodium positive, the core charge will be 11 minus the internal electron, which is just 2 in this case because the valence electron is removed. So only have 2 shells now. So 11 minus 2, you get positive 9. Magnesium 2 plus, again, you have 12 proton number minus the internal electron, which is 2, just in case, is 2, 8. This one also 2, 8. All right, so internal electron is 2. So therefore, 12 minus 2, you get 10. So yeah, magnesium has a higher core charge, therefore it has a smaller radius. Sodium has a lower core charge, therefore it has a larger radius. Okay, so this one is larger radius. This one has a smaller radius. All right, number 9. Now explain why is it harder to remove an inner shell electrons than a valence electrons from an atom? The answer is very easy. An inner shell electron experience stronger effective nuclear charge. Okay, hence more energy needed to remove it. Hence, more energy needed to remove it. Okay, so that's the answer. You just need to explain one of it. You don't have to explain both because it's either you explain, okay, valence electrons, that will be opposite. If you explain in terms of valence electrons, then it will be experiencing weaker effective nuclear charge. I mean, I just write a short form, you should know that, effective nuclear charge, all right? But sorry, in exam, you have to write the full words, all right? All right, number 10. Explain why sodium form positive 1 ions, but magnesium form 2 positive ions. Now, the answer is very simple. Again, in order to achieve a stable electron configuration, an element needs to release its valence electrons. Therefore, sodium has 1 valence electrons, magnesium has 2 valence electrons. That results in positive 1 for sodium, 2 positive for magnesium. That's it. All right. Okay, 11. Use strand to predict which atoms will have a larger ionization energy. So we are done with atomic radius. Now we talk about ionization energy in detail. So again, is the energy need to remove electrons from it. Now, which one should have a larger ionization energy? Sorry. Which one have a larger ionization energy? The one with lower core charge or the one with higher shooting effect? Like I said, shooting effect is always state dominant. So the one with larger shooting effect should have lower ionization energy. The one with a lower shooting effect should have larger ionization energy. Okay, so I repeat, an element or atom with low ionization energy should have larger ionization energy. Wait, what am I doing? Sorry. And atoms or elements with lower shooting effect, larger ionization energy. An atom with higher shooting effect, lower ionization energy. Okay, so that's the final statement. Sorry for that. So let's check sodium and oxygen. So in this case, sodium and oxygen. Obviously, sodium has more shells than oxygen because oxygen only have 2 shells from period 2. Sodium is from period 3. Hence, which one has a larger ionization energy? Oxygen. Okay. Between iodine and neon, definitely neon because it has a lower shooting effect, less shell. Next, beryllium and barium. Beryllium and barium both in the same group, so beryllium should have less shooting effect. Beryllium. Argon and fluorine. Argon and fluorine, definitely fluorine. Less shell, lower shooting effect. Calcium and francium. Francium will have high shooting effect because it's far at the bottom of the periodic table. And calcium is lesser, so I would say the one with the larger ionization energy will be calcium. And at the same time, if you look at calcium and francium, calcium should have stronger core charge or higher core charge for this. Okay, all right, let's move on. Okay, the first ionization energy for sodium, silicon, sulfur are given here, but not necessarily in that order. So assign a value and explain your reasoning. So let's assign them. Sodium, silicon, sulfur. If you refer to your periodic table, all 3 within the same period. When you move across a period from sodium to silicon, silicon to sulfur, we know that core charge increases, shooting effect stays relatively constant. Okay, so when core charge increase, more energy needed to remove an electrons from it. So the one with the highest ionization energy will be sulfur. This is the highest, followed by silicon in between them, and sodium will be the lowest, which is 0.5. Okay, and once you have assigned, explain, like I explained just now, because moving across a period from sodium to sulfur through silicon, core charge increases, shooting effect remain relatively constant. Okay. Now, the following table lists successive ionization energies for 3 elements A, B, C. Why is the second ionization energy always greater than the first? Now, why the second ionization always greater than the first? Because second ionization energy involved the removal of electrons from a positively charged ions, which has a stronger core charge or nuclear charge. Okay? Why is there's a big jump value between second and third for C? Let's look at C. There is a big jump in terms of its ionization energy. See, 1,400 to 7,740. So whenever there's a big jump means there's a change in shell. Very simple. Now, I give you an example. When you have a big jump between second and third, it is something like that. Let's say I have a configurations is 2, 8, 2. All right. Let's say this is for a C example. So if I have these configurations, when I remove the first electron from the valence shells, okay, I have 2. And then when I remove the second electrons from a positive ions, because I removed 1 just now, then it will steadily increase from 700 to 1,400 double. All right. So once I have removed 2 electrons, there's no more valence electrons. And the third electrons here is actually from the inner shell. Okay, this inner shell should experience a stronger core charge or effective nuclear charge, stronger attractions. Therefore, much higher energy needed to remove the third electron from the inner shell. Okay, so that's the reason why there is a big jump from second to third. Now, how to phrase it in the answer? So it's very simple. Just say that why there's a big jump between second and third, because the first 2 electrons are being removed from the valence shell or the outer shell. The third electrons is being removed from the inner shell, which experience a stronger effective nuclear charge. Okay, that's the answer for number 2. Same goes to A, because the first 3 electrons are being removed from the valence shells. The 4th electrons is being removed from the inner shell, which experience a stronger effective nuclear charge or core charge. All right. So what would you expect to the charges on the ions formed by ABC? So we check the big jump. We will actually know the groups that they belongs to. All right. So the groups that the element belongs to, let's check. So A, the big jump is between, this is first, second, third, and fourth. So the big jump is between third and fourth. So which means this is from group 13 or group 3. And here the big jump is between first and second. So this is from group 1. And C again is a big jump between second and third, like we explained just now. So this is from group 2. All right. So if that's the case, A will be from group 13, so it will form 3+ because you have 3 valence electrons. And B will be group 1, so it's just positive. C will be from group 2, so it's 2 positive. Okay, that's answer number 3. 14. Circle the atoms in each pair that has a greater electronegativity. So between lithium and oxygens, which one having a higher electronegativity? Again, look at the trend across the period. Core charge increases, shielding effect stay constant. So they are getting more and more electronegative when you move across a period. So lithium and oxygen, of course, oxygen. Chlorine and sulfur across a period. Chlorine at the far right, so chlorine should have high electronegativity. Bromine and arsenic, they are within the same period as well. So bromine is on the right, so bromine, because getting higher core charge, should the effects stay the same. Barium and strontium, they are in the same group. Going down the group, electronegativity decreases because of the higher shielding effect. So they want a greater, so answer is strontium. And oxygen and sulfur in the same group, oxygen should have a greater electronegativity due to a lower shielding effect. Because they're in the same group, core charge will be the same. Okay, 15. The following table shows the ferrous ionization energy of some elements in group 17 and 18. So in this case, you just need to estimate the value here, okay, based on the trend that we learned. So in this case, we know that going down the group, the ionization energy is supposed to decrease. So the value for chlorine should be smaller than, let's say, X here. So X should be smaller than 1680, but it should be greater than 1140, all right? And here Y, so Y should be same thing going down the group, even though it's group 18, which is inert, the same trend will be used. So it should be smaller than 1520, and greater than 1170. All right, so that's the any values within this range. It's fine. Okay, 16. Explain the following trend in successive ionization energies for any individual element. So why the third ionization energy is the greatest, followed by second and first? Because the third ionization energies involve the removal of electrons from a positive 2 ions, which has higher core charge or effective nuclear charge. All right. Second ionization energy, basically they are the same thing, just that of course the details will be slightly different, is the removal of electrons from positive 1 ion, which is slightly weaker in terms of the core charge, and the first ionization energy is actually removal of electrons from a neutral atom. So in that case, first ionization energy, the electron should experience the lowest core charge or the effective nuclear charge. So the energy needed to remove it will be the lowest, followed by second, slightly higher because it's positive 1, and the third is positive 2 ions. All right, so that's 16. 17. Now the graph below shows the successive ionization energies for neon. What is the electron configuration for neon? So is 10, so 2, 8. Explain the shape of the graph. Okay, the ionization energy steadily increases from 1st to 8. Okay, the ionization energy steadily increases from 1st to 8. And there's a big jump between 8th and 9th. Okay, so this is just to explain the shape. You just state the trends out. So steadily increase from 1st to 8, and from 8 to 9, there is a big jump. And why there is a big jump there? Very simple. Still remember that? Whenever there is a big jump means the first 8 electrons are being removed from the valence shell. The ninth electrons is being removed from the inner shell, which experience a stronger effective nuclear charge, stronger attractions. Therefore, there's a big jump. All right. To write electron configurations of argon. Argon is just below neon, so it's 18. So it's 2.8.8. All right. Additional shell. Make a sketch of the graph of successive ionization energies for argon. So you need to sketch it out roughly. In this case, we can see the configurations that argon has an additional electron shell. So overall, generally, the ionization energy should be slightly lower. So the graph should be lower than neon, slightly lower the line, and then shoot up at the same point. Why they shoot up here between 8 and 9? Again, because argon also has 8 valence electrons. And then the 9th electron, after you remove this, will be from the inner shell, which experiences stronger nuclear attractions. Okay? So that's it for this. Moving on, 18. Give the name of the following. So a gaseous element at room temperature in period 3 of the periodic table. So period 3, if you check the periodic table, this is, I can give chlorine. Okay. A group 14 element that is non-metal, I can give carbon, because silicon is a semi-metal, after that it's a metal. Group 2 and period 2 elements. Group 2 and period 2 elements, I would say is beryllium. Only one answer. Transition metals that form blue color compound, this is commonly known copper. The period 4 elements with 7 electrons in its outermost shell. Period 4, 7 electron means from group 17, so it's bromine. And group 2 elements whose atom has more proton in the nuclei than calcium atoms. Anything below calcium atoms in group 2 will have more protons in its nuclei, so I would say strontium in that case. All right, 18. This is for reference. 19. Now, the first 6 successive ionization energies of element X are listed below. So, to which group of the periodic table does this element belongs to? Look for the big jump. The big jump, from what I can see here, is okay. That's first, second, third, fourth, fifth, and sixth. Okay, so 6 electrons are being removed here, and these are the successive ionization energies. So I can see the big jump from third to fourth, which means element X is from group 13. Okay, nothing wrong if you write group 3 in the Roman style. So either way, all right. Now, what evidence given in the ionization energy data establishes X cannot be a period 2 element? Now, first, this is a bit tricky here for question B. First, element X given with 6 successive ionization energies, which means minimum number of electrons should be 6. So you should have a minimum of 6 electrons because they give 6 ionization energy data, minimum of 6. It can be more because they just first 6. All right, so that's the X. Now, next, we look at the conditions. If X were from group period 2, now if it is from period 2, means I only have 2 shells. Something, dot something. And from here, we know that X is from group 3. So I should have 3 valence electrons in the outer shell. And the first shell, the number is always 2. So this is the only valid configuration for period 2X. And how many electrons here? Equals to 5. But we know that X should have a minimum of 6. Therefore, X cannot be a period 2 element. Okay, so that's for B. Okay, last questions. Choose the letter that best represent the position of each of the elements described below. So the metal with the largest atomic radius. So going down the group, atomic radius increases. Going across, atomic radius decreases. So answer for this is F. Group 17 elements refer to group 17 with higher electronegativity should be increasing down the group. So answer is B. A non-metal with 6 electrons in its outermost shell, group 16. I believe that's I, which is here. Okay, this is the answer. If it is it's a bit not clear here, the letter. So, and elements in group 13. Elements in group 13, so it's just right after the transition metal, so it's H. The elements with core charge of +4. Okay, core charge of +4, it should be from group 14, which is M. Let's say, let's take group 14 elements as an example, carbon. Carbon should have 6, so 2, 4. Okay, and what is the core charge? 6 minus 2. 6 minus 2, the internal electrons, you get a +4. So yeah, that's proof that all group 4 elements or group 14 element has a core charge of +4. Okay, if you can check silicon from the periodic tables, and then you will get +4 as well. Okay, F. The period 2 elements with the highest first ionization energy, it must be period 2. So we know that this is period 1, P1. This is actually P2. A period 2 elements with the highest first are E. Ionization energy decreases down the group, increases across a period. So in this case, the answer highest first IE will be B. Okay, same period, but across a period, the one on the far right should have the highest ionization energy. So an element in group 2. An element in group 2, so this is group 2. Definitely the answer is just 1, G. A metal in period 3. Again, the answer is H. The element with the highest first ionization energy, again, first ionization energy, is the energy involved to remove an electrons from it. Okay, the energy involved to remove an electrons from it. So the one with the highest first ionization energy will be A. Okay, the one with the lowest electronegativity. Lowest electronegativity means if you look at the trend, going down, decrease, across, increase. So it should be the bottom left corner, should be F. Element with the highest electronegativity, again, highest core charge, strongest attractions. So again, it should be A. Okay, so that's the answer for question 20. So that's it for tutorial 1. I'll see you in our live tutorial session. So please watch the video. And if you have any questions, jot it down, make a remark, and then you can ask in the tutorial sessions. Why do I make a video like that? Because we can spend more time on discussion during the tutorial instead of explaining question by questions, and you guys have no chance to ask questions within 2 hours. So it's better to go through that first, pre-watch it, and then we will explain in further details during the tutorial sessions. All right, so that's all. Thank you for watching, and then I'll see you in tutorial sessions.